So I forced my inputs to be, for this one is 7 and this one is 0, and my selector is 0 0. So 0 0 selector causes the OR operation to happen, and so we have 1 or 0, 1 or 0, 1 or 0, 0 or 0, and then you force the clock down, and I'm about to force the clock back up. So force clock to 1. I spelled it wrong. 100. Alright, now we at the next operation. Next operation is NOR, which would be the opposite. So 1 NOR 0 is 0, 1 NOR 0 is 0, 1 NOR 0 is 0, 0 NOR 0 is 1. So you see my output and you see the selector go to that. So then we're gonna, once again, we have to force the clock back to 0. Run 100. Force clock back to 1. Run 100. And we are at the next step. Alright, the next one is not input 1. So we got input 1, we got 1 1 1 1. You see it switched with the selectors and a 0, so it should output, it doesn't matter about this, it's 0 0 0 1. Alright, now force the clock back down to go to our final state. Run 100. Force clock back to 1. Run 100. Okay. And our last one is XOR. And XOR will be 1 and 1 is 0, 0 and 1 is 1, and 0 and 0 is 0. So we got 1 1 1 1, so we got 1 0 0, so we got 1 1 1 0, which will be the same as the other one. And you see my selector is at 2, and when it's at 2, it does the XOR. And this is my waveform. And let me drag reset over there. Okay, now we're just gonna force reset to be 1. And when you force reset to be 1, as you see, the output resets to 0 and the selector resets to 0. And I just added that, so it just popped up with this little right here. And yeah, that is the ALU using components with the finite state machine controlling the operations. Alright, so I got input 1 being binary number 1, input 2 being 0, because when the output is 1, you'll jump to state 1. Output is 2, you'll jump to state 2. Output is 3, you jump to state 3. Output is 4, you jump to state 1. No, output is 4, you jump to state 0. Output is 5, you jump to state 1. Output is 6, you jump to state 2. And output is 7, you jump to state 3. And everything else, you're just going to be ORing it, which is going to be state 0. Alright, so see my temp, but it only changes on the rising edge of the clock. So I forced my clock to be 1, so now we just have to hit run 100. And you see we go to state 1. Now if I did another run 100, we would just skip back to state 0. So for this reason, I'm going to force my clock to be 0, which would allow me to remain in the same state and perform any operations I choose. Video cut off, somebody called me. Are we back though? We in state 1. When we gonna remain in state 1 because I just forced the clock to be 0. So now I'm about to change my input. Well, actually, I can just show you guys. I'll just show y'all that it goes right back to state 0 because of the output being. You see the output with the output being higher than 6, higher than 7. It'll go back to state 0 just for the OR operation. So we're gonna force the clock back to 1. Just show y'all that. run 100, you see, boom, we jump back to 0 because the output is 1 of the last operation. So you feel me? Yeah. Okay, so now we're gonna try to go from here. We're gonna do force 0 and we're gonna go back to state 1, and then from state 1 we're gonna go to state 2. And then we're gonna go to state 3, and then I'm gonna show y'all. Dang, I forced the clock to be 1 again. I got forced it to be 0. Force clock to be 0. 100. Force clock to be 1. 100. Boom. As you see, we're in state 1. Alright, now I have to force for me to get when state 1 is NOR. So that is why it does that. So what I'm gonna do is I'm gonna make input 3 1. Alright, so what I did was I'm about to run 100, but I forced the input 1. So I forced this to be binary number 8, and 8 should turn into 7 when you NOR it with all zeros. And we're gonna do run 100, and you see we stayed in the same state because the clock is 0. I made sure the clock, when you're in the clock is 0, you would not move to the next state based off the output. It would just keep updating the output. But when the clock is on the rising edge, as we're about to show you, force clock to be 1. Since we have 7 on the output, we should jump, according to what I wrote, we should jump to state 3. And the state is represented by the selector, which right now we're at state 1. Okay, so we're gonna run 100. Boom, see, we jumped to state 3 because our output was 7, but now our output is 8. And anything over 7 will automatically jump back to state 0. And so I can show y'all that. But we want to go to state. When you're in state 3, it XORs the inputs together. And so I'm gonna show you that if we force the clock to be, force the clock to be 0, and then run 100, and then force the clock to be 1, run 100. Boom. As you see, we jump back to state 0, and now our input is 8 still, so we would jump all the way back because now we're in the OR state. So it just ORed 0 0 0, so it ORed 1 and 0 to get 1, and when you get this over 8 as your output, you're going to jump to the 0 state. So if we want to jump to this only state we haven't hit yet, which is 2, which is not input 1, we'll have to do a simple force input 1. We're going to force the 8, the binary number in the fourth slot, back to 0, and I'm going to force input 1, the 2 spot to be 1, because when you get a 2, according to this, when you get a 2, you jump to state 2. Messed up. Force input 1, 1. I'm gonna force that to 1, and we're gonna do, I think the clock is at 0. Let's force the clock to be, no, the clock is 1, so let's force the clock to be 0, run 100, have everything update. So we got this updated, so that's 2 or 0 equals 2. So once our clock is 1, we should jump to state 2. So that is the last operation I didn't show you guys. If your output is over 7, you automatically jump to state 0, which is just OR. Kind of gives you more direction on where you want to go next. Alright, first clock to be 1, run 100. You see, I jumped to state 2, and state 2 represents on the ALU state, when you're in state 2, it's not input 1. So as you see, input 1 is 0, 1, 0, 0. So not input 1 would be 1, 0, 1, 1. And I'm in state 2. Thank you.